Okay, in this video we're going to start talking about 6.4, section 6.4, factoring, that's this one right here, the AC method of factoring. So the issue arises when we multiply two binomials where it's not just x times x. What's going on here? We have coefficients of 2 and 3. So this complicates things because when we FOILed it out, we got 6x squared. So this is considered the leading coefficient, and it's not 1. Okay? So if we were gonna factor this, when we FOILed it all out, we got this. If we factored it, we would have to say, we couldn't say, well, what two numbers multiply to 2 and add to 7? First of all, there are no two numbers that multiply to 2 and add to 7. You notice that? Okay, so we actually have to consider the 6. So we have to say, okay, well, what times what gives us 6x squared? If I'm factoring it, already I FOILed it and I know what the answer is, but let's say I didn't know what that answer was. Okay, and I wanted to go backwards now and I wanted to factor this. I would have to say, okay, well, what times what gives me 6x squared? 6x and x could give me 6x squared, right? 2 and 1 could give me 2. But if I FOIL that, I would get 12x plus x, which is 13x. That's not what I have in the middle. Do you see what I'm saying? So I have to try again. This is what we call trial and error. You just keep trying. Okay, well, 6x squared, maybe 2x times 3x, 2, 2 and 1. Positive, positive. Okay, now let me FOIL. That is 2x. This is 6x. But that adds to 8x. That's not the 7x I want. So do you see that the problem, I could be doing this all day? You know, especially if the numbers were bigger. These numbers are not that big. 6x squared only has the possibility of 6 and x and 2 and 3. You know what I mean? To get that 6x squared. And then 2 is prime, so I only have the option of 2 and 1. So even with trial and error right now, I would have to try and fail a lot of times in order to get it. So there is this other method, and this is a very systematic way of factoring when the leading coefficient is more than 1. So now that we've practiced the trial and error method for factoring trinomials with the leading coefficient of 1, that's what we did in section 6.3. We're going to move on to the general case of trinomials. Many of us prefer an organized procedural approach to factoring. The AC method is one organized technique for our work. So you can take a moment to pause the video and write down these steps. Essentially, we're considering the polynomial in this form. So this is a trinomial, and it's a quadratic because it's x squared. A is just the coefficient of x squared, B is the coefficient of x, and C is the constant. So the very first thing we're going to do is identify these numbers, A, B, and C, the coefficients, right? We're going to set up a table of factors, and we're going to multiply A times C. That's why this is called the AC method. And those two factors then, instead of, normally we were just factoring C, the last term. And then the two numbers had to add to a sum of B. Now, A times C has to have a sum of B. We're going to write the new polynomial with 4 terms and then use factor by grouping. I think we learned about factor by grouping in 6.1, okay? And we're going to check by FOIL. And that we learned in chapter 5. So this is all, again, sounds like, what is going on? Well, we have a very organized approach, so this will all make sense if I show you an example. We're going to factor the polynomial with the AC method. First thing we have to do is notice how messed up this polynomial is. So we want to always write it in descending order. If it's not written that way, what is the descending order? 6x squared minus 5x minus 6. Very good. So, and now identify A, B, and C. A is equal to 6. B is equal to negative 5. C is equal to -6. So we've done the first step. Write the product of AC. What does that word product mean? Yes. 6 times -6. AC equals 6 times -6. What is that? That is, what does A times C equal? -36. Good. Fill in the table by giving the sum of each factor pair. So now what they did right here, this list, what is this list right here? The factors of this one, this list right here are the factors of -36. Normally you would write that table, okay? It's filled in for you here. What we're going to do is we're going to do what we just did in the last one. Instead of factors of just -6, we did -36, and we're going to add those two numbers together. So what's 1 plus -36? What's 2 plus -18? What's 3 plus -12? What's 4 plus -9? What's 6 plus -6? Okay, so what this list right here is M and N are the two numbers that multiply to equal the product of the AC. In this case, 36. So these are all the factors of -36. And then here, M plus N are the two numbers that add to equal B, the middle term. Which one of the pairs equals to B? So here's B. Which pair do we want to use? Because that's the magic combination that gives us the -5, okay? So find the integers m and n such that m and n multiply to AC, -36, and they add to b, which is -5. So we found those two integers. So AC was -36 and b was equal to -5. The integers m equals 4 and n equals -9, because 4 times -9 is -36. 4 plus -9 is -5. Okay, so that's basically, it's very similar to what we just did in the last lesson, correct? It's just now we're considering this very first term, the 6. Okay, so now we're going to use this information to rewrite the middle term of the polynomial. I'm going to write this as 6x squared. Instead of -5, I'm going to replace this with -9x and positive 4x minus 6. So do you see that those two middle terms, don't they still add to -5? So I didn't really change very much about the polynomial. I just broke up that -5 into two numbers that add to -5. You're with me so far? Okay. Now, when we have a polynomial with 4 terms, do you remember how we do the factor by grouping? We group the first two, we group the last two. And by the way, I could put that order could have been either way. I could have put the positive 4x and the -9x. It doesn't matter. In the middle, right? Okay, so now what's the greatest common factor of those two first terms? 3 and x. 3x, right? If I divide out 3x, what do I get? Because notice I'm pulling the x out as well, right? Because they both share an x. So that x comes out. Now, what's the greatest common factor of the last two? So 2 comes out, and what gets left behind? Oh, and remember that they have to have a match, right? I have this binomial right here is a match. So now I factor out the 2x minus 3, and what's left is 3x plus 2. That's factored. Factored completely, that's what it is right there. I use the factor by grouping. Okay? How could I check to see if this is the right answer? Yes, you could FOIL. I don't have enough room, but you could also FOIL to check. Okay? I'm not going to do that right here, but you could also do a mental FOIL. You could go, oh, that would be 6x squared. Here's a positive 4. Here's a negative 9. You know, that's going to give me negative 5. And then the last, negative 3 times positive 2, is going to give you that negative 6. So that's just a mental FOIL. Okay? Let's go on to the next page because we have several more examples. So the very first thing that we're going to always want to do is we're always going to want to look and see, is there a greatest common factor? If you look at this, I see the 3 and I see a 6. But what's the problem? Is there a greatest common factor that goes into everything? No, why? 17. Yes, okay? So we're going to do the whole thing right now. First step. What's the very first thing I need to do? I need to multiply these. If I have a leading coefficient of more than 1, I have to multiply them. So I have 3 times negative 6 is negative 18. That's the number I'm factoring. I'm going to take A times C. And then I'm going to look for those factors. They have to have a sum of B. B equals negative 17. So can you think of any two numbers that multiply together to give you negative 18 that add to negative 17? Times 1. So I'm going to break up the middle term. I'm going to rewrite, this comes down 3x squared. This comes down negative 6. I'm going to rewrite the negative 17x as negative 18x plus 1x. Does everybody see why I did that? I'm breaking up the middle, strategically breaking up the middle, in order to be able to factor by what? Grouping. By grouping. I don't use parentheses when I do grouping because otherwise it looks like it's factored. So I'm grouping these. What's the greatest common factor of the first two? 3 and they both share an x. Yeah. Okay, what's left when you factor out 3x? X minus 6. See, one of those x's gets divided out because they both share, right? So that's why you're not getting x squared here because you're dividing out an x. You're factoring it out. Yes. Now, what is the greatest common factor between x minus 6? It's 1. So I would put plus 1 x minus 6. The reason why that 1 is important is because when you go to the next step, what are your two binomials? Well, you're going to factor out the x minus 6, right? So what do we get? X minus 6, 3x plus 1. So the x minus 6 gets factored out, right? You're taking it out. That's why it's first. And then what's left is 3x plus 1. That's what goes inside that second parenthesis. Okay, let's try another one. So we just need lots and lots and lots and lots of practice. And if you have questions that are coming up, let me know. So what's the very first step? Yes, AC. That's 12 times 5 is 60. And we want to have a sum of what? 23. Okay? Now you might think of the magic pair. You might have to go 1 times 60. Well, that's 61. 2 times what? 30. That's 32. Okay? 3 times 20. That's 23, right? So I'm thinking of the factors and then I'm just adding them together. Didn't we find the magic pair? Does it make sense how we got that? Okay, now we rewrite 12x squared, and then it doesn't matter which order you put these in. You could do plus 3x plus 20x plus 5. And you know, that came up when we were talking about factoring by grouping before. Which ones are a better match, you know? I'm going to eventually group them up. So I think 3 goes really nicely with 12. They would be a good couple. I think 20 goes really well with 5. I think they would be a good couple. It doesn't actually matter which order you put that, because remember, that's the commutative property of addition. 20x plus 3x is the same thing as 3x plus 20x. So it doesn't matter which order you put them in, but you might think one goes better. Does that make sense why one kind of goes better than the other? Just makes it a little easier when you factor. So what is the greatest common factor between these two? 3 and x. If you factor out 3x, what do you get? Plus 1, good. And then what about now this one? 5, so that's plus 5, positive 5. 4x plus 1. So you'll know you did it right if these are a match. Okay, you're looking for those because now the only way you can proceed, if these are a match, you're going to factor out the 4x plus 1 and what gets left behind. Okay, so we'll stop the video there so that we can do the next one in part 2.